Hello everyone, welcome to rotational dynamics, angular momentum plus its conservation. So here angular moment is defined as the moment of linear momentum. So that is L equals to P into the perpendicular distance R. So here we're going to prove that linear momentum is equals to I omega. So here what we always do is take a rigid body with n number of particles and we have an axis of rotation y dash and we take their perpendicular distances. So here particle m1, particle having mass m1 with perpendicular radius r1, m2 with r2, so on for mn, rn. Now here the angular momentum for the first particle is p1 into r1, which is mass 1 into velocity into radius 1. So here we can write velocity as omega r1, and here the angular momentum is the angular velocity is the same for each and every particle. So this becomes m1r1 square omega, and for L2 similarly we'll get m2r2 square omega, so on for Ln, mn rn square omega. Now here the total angular momentum of the body is equal to the sum of the angular momentum of individual particles. So I'll take common m1 r1 square plus m2 r2 square plus dot mn rn square into omega. So from here we get L equals to, this is just moment of inertia into omega, thus this is the required expression. So now time for the conservation part, the statement of conservation of angular momentum. So if you guys have remembered in linear momentum, the conservation of linear momentum is that if no external force is applied in a system, the total linear momentum of the system remains conserved / constant. So similarly for angular momentum, we just change a few words, the few analogies. So it states that if no external torque is applied in the system, then the angular momentum of the system remains conserved / constant. What this means is that I omega equals to k constant, therefore meaning I1 omega 1 equals to I2 omega 2. Now this is a very important chapter as it will come in very many conceptual questions, and it is actually very interesting as well. So here according to the statement that no external torque is applied, so tau is equal to 0. Now here I forgot to prove one part. So we have L equals to I omega. If we take the rate of the angular momentum, we get I d omega by dt, as I is constant, giving us dl by dt is equals to I alpha, and we know I alpha is just tau, therefore tau is equals to dl by dt. So here we can write dl by dt is equals to 0, and now what we do is we take the dt over here, so we get the change in angular momentum is 0, and by definition we can write that I omega is constant, but let's do it mathematically. So we integrate both sides, and the integration of 0 is a constant. So here this becomes angular momentum is equals to constant, therefore I omega equals to constant, which gives us I1 omega 1 equals to I2 omega 2. Now this can cover a lot of questions, such as, if the ice on the polar caps of Earth melts down, what effect will this have on the time duration of the day? Well, here, if the ice caps melt, the mass will be collected and from the the edge of the world to the center. So that means the central mass of the world will increase. That means if mass increases, then moment of inertia also increases, right? Because I equals to mass into k square, which is radius of gyration. So if momentum increases, what this means is that angular velocity will decrease. So that means that the earth will start rotating slower. That means we will have more time in one day. So that means the time duration of the day will actually increase. And we have similar questions related to this one, such as why do ballerinas spread their arms to, come to rest or to slow down? Well, because if the ballerina dancer stretches her arms, then the perpendicular radius from axis of rotation will increase, so moment of inertia will increase, thus the angular velocity will decrease and she will start slowing down. Similarly, you also ask why a swimming diver, right? They call up into a ball while performing a trick or performing, because well the radius will decrease, the permanent distance will decrease, that moment initial will decrease, and angular velocity will increase. So the diver will start spinning faster, and in the end, the diver will stretch their arms to, well, because of the same reason, right? The reverse reason. This. She will face less of an angular velocity. That means she will face less torque. That means she will face less force, and well, they will not get injured. And we'll have similar questions like that, conceptual questions like that, in which either the mass changes or the radius changes, thus from that corresponding moment of inertia changes, thus omega changes, and most frequently it's asked what will this effect happen on the time duration of the day. So this is it for angular momentum and its conservation. In the next video, I'll do the kinetic energy of a rolling body and the acceleration of the rolling body in an inclined plane. Thank you.